Hello everyone and welcome to 30 Days of Java. It's day 24 now and today we'll discuss about Stream API in Java. In this video, we'll look into the Java Stream API, why we need it, and also the type of operations it offers. So let's get started. The main reason why Stream API is preferred over normal approach is it provides a more expressive, concise, and efficient way to process collection of data. It focuses on what needs to be done rather than how to do it. The Stream API leverages Lambda expression and method references, enabling a functional programming style that can lead to more flexible and reusable code. It also provides performance improvement as it uses lazy evaluation, which avoids unnecessary computations. In the example shown, we have created a program which has a list of integers and it outputs all the integers that are greater than 5. By using Stream API, we don't need to define the whole for loop, and we simply focus on the result instead of the implementation. While the following program may appear straightforward, the advantages of the Stream API become significantly more apparent in complex scenarios, often encountered in production environments where it becomes a valuable tool. Now that we know why we need it, let's understand how it works. By taking a simple real-world example. Imagine you have a water filtering mechanism which filters and cleanses the contaminated water and provides clean drinking water. In the following setup, the water tank works like a source, which in Java terms would be a collection, and the water inside it are its elements. The flowing water would be considered as a stream, as the name suggests, which is routed to a water filter that represents the Stream API operations. And finally, the clean water would denote the process data. The Java Stream API introduced in Java 8 provides a functional programming approach to processing sequences of elements such as collections. It allows for efficient and expressive manipulation of data through a series of operations that can be chained together. The stream operations are divided into two categories: intermediate operation and terminal operations. Intermediate operations transform a stream into another stream, whereas terminal operations provide a non-stream result like list, integer, or a side effect. Another important difference between them is that intermediate operation employs a lazy execution approach. That is, they are not executed until a terminal operation is invoked, and terminal operations uses eager execution, which triggers the execution of all intermediate operations. You can have multiple intermediate operations chained together in a stream, but there would only be a single terminal operation in it. Now let's try everything that we have learned so far on IntelliJ. Now let's start with a basic example. So for that, I'll create a list of integers. I'll name this as list. Then for its elements, I'll initialize it to arrays.asList. Then I'll give it values 1, 2, 3, 4, and 5. Now we have a list of integers that have elements from 1 to 5. Now suppose if I want to output only the elements that were greater than 3, then using Stream API, I can write it as list.stream, which converts this collection into a stream, then filter, and then inside this filter, I have to pass in a lambda expression. If you're not aware about lambda expression, you might want to rewatch the previous video, that is day 23 lambda expression. So coming back here, I'll type in item, and if the item is greater than 3, then we'll call for each loop and will simply output those elements. Now let me clear this up a little bit. Okay, before running this program, let's go through it first. So first we have called the stream method that converts this collection into a stream of elements. Then we are passing that stream to a filter method which takes in this lambda expression, which ultimately is checking if the element of that list is greater than 3 or not. So first it would go to 1 and check if 1 is greater than 3 or not, then for 2, then for 3 and so on. Finally, this filter method returns back another stream which is passed to for each method. And for each method outputs those elements into the console. So now let's run this program. And you can see it outputted 4 and 5. Now I can also chain together another intermediate operation into this stream. So suppose after filtering out the stream, I want to multiply all the elements of that stream with 5 and then give its result. So I can simply use another intermediate operator, that is map. And here I'll also need to pass in a lambda expression which is x asterisk 5. Now map function manipulates the elements of that stream before passing it on to the terminal operation. So if I run this program, you can see it multiplied the output by 5, that is 4 multiplied by 5, that is 20, and then 25. Now another thing to note here is that this map operation is not making the changes into the source, that is the collection list. So suppose if I output the values of list after the stream and run this, you can see in the output it first outputted 20 and 25, but in the original list, that is 1 to 5, it didn't make any changes. So always remember, while using Stream API, it doesn't make any changes into the source. If you want to get back the manipulated list, you have to store it in a new list. Another thing to note here is that you can use the Stream API with custom objects also. So here in this example, I have a cat class that have a few properties, that is string name and then int age. And then I have a constructor for cat class. Now if I create another list of cat objects, and let's call this cat list, then I'll simply type in new array list. Now I'll add some objects into this list. So suppose if I only want to fetch the list of cats that have age greater than 15, then I can simply type in as cat list dot stream dot filter, and then I'll type in x dot age greater than 15. Then for each now let's comment this out first. and run this program. Okay, we need to make a change here. Instead of passing the x here, we need to pass in x.name. Now if I run this program again, you can see it returned back the name of the cats that have age greater than 15. Now I can also sort this list by simply typing in sorted and then comparator dot comparing, and then I need to pass in x dot name. So with this sorted method, I'm passing in a comparator here where I'm telling the compiler that it needs to sort the list of cat objects based on its name property. So if I run this program now, you can see it printed out the same thing because it's already in sorted order. So suppose if I change this to Z and now run this program, it would return back the list in a sorted order. If I remove this and then run this program, it prints it out in an unsorted order. So this is how Java Stream API works. Now there are a ton of different operations in Java Stream API that you can use based on your scenario. So if I simply type in dot, you can see the list of all the operations that Java Stream API offers, like map, filter, sorted, for each distinct. So this method can be used to filter out all the distinct elements of a list or collection. Then there are other methods like limit, which limits the number of elements that it would output, and so on and so forth. As always, we'll end this video with a quote that says, "A gem cannot be polished without friction, nor a man perfected without trials." Thank you for watching and have a great day.